3.6 is more factoring and graphing. We're going to be doing more of what we did in 3.5. So our essential question, how do you use factoring to help graph? So this is kind of like what we did the last 3 examples of factoring by grouping. Let's read the directions. For examples 1 through 3, factor each function completely over the integers, find all the roots, otherwise known as zeros, and sketch. So when we sketch, remember we also have to find our end behavior and our y-intercept. Example 1. The first thing we need to do is factor. I notice there's 4 terms, so we are going to be grouping. Go ahead and group the first 2. Remember, when there's a minus, we put a plus in the middle and put the minus with the number. Step 1, group. Group the first 2, group the next 2. Step 2, find the GCF of your groups. Here, my GCF is x squared. And then I'm going to have an x, because x squared times x is x to the third. And then a 4. X squared times 4 is 4x squared. Let's look at our next chunk. Remember, when this number is negative, we're going to have a negative. Here, 9 and 36, that's going to be a 9. It's going to be an x. Negative 9 times positive 4 gives me negative 36. We have our common binomial. And then what were the GCFs? X squared and negative 9. Are we done yet? We are with the grouping, but here I have a difference of squares. So I have x plus 4, x plus 3, x minus 3. Okay, I'm going to go ahead and give you time to find your x-intercepts, or we also call them the roots and zeros, and the y-intercept and the end behavior, so that way you can sketch it. Go ahead and pause the video so they could do those last few things. The end behavior, our leading coefficient is a 1. Our degree is, if we look at our original, it's 3. Or if you look here, we have 1, 1, 1. This means we're down, up. For our x-intercept, we make y equal to 0. So I set all of these equal to 0. Here I get negative 4, negative 3, positive 3. And then we write them as x-intercepts. Last piece for our y-intercept, we make x equal to 0, so y equals 0 plus 4, 0 plus 3, 0 minus 3. And I get 4 times 3 times negative 3. That's also going to give me a negative 36. Writing it as a y-intercept, we have 0, comma, negative 36. Let's graph it. The x-intercept -4, -3, +3. Let's check. Did they all have a multiplicity of 1? Yes. And then we have -36. We're down up. So we're going to go up and down and up through there. Number 2. Our first step should always be to look for an overall GCF. So is there something that goes into all 4 of those? Number-wise, I have a 4, 29, and 45, so no. And I'm ending without an x, so I can't take out an x. I'm going to go ahead and have you try this one on your own right now. So go ahead and pause the video, have them try this. Now that you've had time to try it, I'm going to group the first 2. I hope you put a plus sign in between and group the next 2. Here, my GCF is 4x squared. 4 goes into 4 and 20. X squared is my smallest. So then I have an x plus 5. Here I have -9x, -45. Whenever this is negative, we're going to take out a negative for that last chunk. 9 and 45, that's going to be a 9. And I get an x in -9, yes, plus 5. So they are the same. My common binomial is x plus 5. My GCFs were 4x squared minus 9. Am I done? No. I have a difference of squares. So that should give me, let's see, 4x squared, 2x and 2x, 9, 3 and 3, 1 plus, 1 minus. For end behavior, you should have gotten down up. Let's see, what's our leading coefficient here? There's a 1 right here. 1, 2, 2. So our leading coefficient is actually 4, but that's positive. Our degree is 3, so it's down up. Our x-intercepts make y equal to 0. I have x plus 5 equals 0, 2x plus 3 equals 0, 2x minus 3 equals 0. Equals -5. What happens here? Subtract the 3, divide by, well, I subtracted the 3. Divide by 2, I get x equals -3 over 2. Same thing here, we're going to add the 3 and then divide by 2. So I get x equals 3 over 2. Let's write these out. This one's -5, 0. I'm going to write this as a decimal, -1.5, and then +1.5. For our y-intercept, we make x equals 0, 0 plus 5, 2 times 0 plus 3. 2 times 0, I need to scoot this over more, minus 3. So we just make all of our x's 0. Okay, this gives me a 5. 2 times 0 is 0, plus 3 is 3. 2 times 0 is 0, minus 3. 15 times negative 3, negative 45. So we get 0, comma, negative 45. Let's go ahead and graph this. Intercept at negative 5, negative 1.5, positive 1.5, negative 45, and we are down, up. Like that. For example 3, we're going to look at y equals f minus g. So remember, when we have that minus, we're going to have to distribute the negative to all of our g. So let's just write this out. Y equals x to the third plus 3x squared. That's my f. Minus, my g is negative 4x minus 12. So I have x to the third plus 3x squared. Minus minus is a plus 4x, minus minus, that's a plus 12. I notice we're 4 terms, so if I factor it, I'm going to have to group the first 2, group the next 2. I'm going to go ahead and leave you to keep working through this. Finish factoring it. Find the x-intercepts, y-intercepts, and sketch. Now that you've had time to keep going, my GCF here is x squared times x plus 3. My GCF here is 4. I have x plus 3 times x squared plus 4. Can I keep going here? It looks like a difference of squares, but it's a plus. So this is not a difference of squares. So we are done. So let's look at our end behavior. My leading coefficient 1 positive. I look here, x to the third, odd, so we're down up. X-intercepts, I'm going to make y equal to 0. 0 equals x plus 3 times x squared plus 4. So I have x plus 3 equals 0, so x equals negative 3. X squared plus 4 equals 0. X squared equals negative 4. Can I take the square root here? Nope, so we have nothing here. This gives me negative 3, comma 0. For my y-intercepts, y equals 0 plus 3, 0 squared plus 4. So this is 3, 0 squared 0, plus 4, that's 4. I get 12. Let's go ahead and graph this. X-intercept at negative 3, y-intercept at 12. We are down, up. So down, I have nothing else to go through, so I'm just going to go up. And there's my graph. Let's go ahead and look at number 4. Example 4. Write in factored form. What does that mean? Well, in factored form, we're going to be like our bottom format here. Go ahead and highlight all of our factored forms. This is factored form. That is factored form. That is factored form. The other form is called standard form. So write in factored form, the equation, note we have that word, the, so we're going to have to find our A for a polynomial given. We're a cubic, so my degree is 3, such that, let's put in, I think there's supposed to be a P right here. P of -1 equals P of 2 equals P of 3 equals 0. So just a reminder of this notation. All of these are x values when y equals 0. So this is saying y equals 0. So what does that mean? Those are x-intercepts. Then I have P of 1 equals -4. So I have 1, my x is 1, y is -4. Okay, so, well, our function is called P, so P of x equals A. We don't know what our leading coefficient is. Now my 0 is -1. My x-intercept is -1. So when I write it, it's a +1. So this is a +2. So when I write it in the factored form, it's a -2. And I have one last one. This is a +3. When I write it in the factored form, it's a -3. Now we get to solve for our A. How do we solve for our A? We use our point. So we're going to plug in 1. 1 is my x, -4 is my y. Let's see, 1 plus 1 is 2, -1, -2. -4 equals 2 times -1. -2 times -2 is +4 A. So A equals -1. So our final answer, P of x equals -1 times x plus 1 times x minus 2 times x minus 3.